So I used to listen to a police scanner all the time when I was a kid, which is why I got pretty excited when I discovered this website here called Broadcastify. This allows people that own scanners to live stream those feeds here where you can then go and listen to them. So check it out. If I go to listen, browse feeds, I can pick any state I want, pick a county, and then there you have a list of all of the live feeds for that county. And you've got things in here like the fire department, highway patrol, the sheriff, their police, all kinds of stuff. And, where I live, there's not much going on. So if I want some action, I'll go over to top feeds. And then in here, yeah, there you've got it. Chicago Police Zone 10, Districts 10 and 11. We've got the fires going on right now in California. So, of course, those are popular feeds here. Yeah, the LA County City Fire there. And I use this all the time. They've got a mobile app for it too, which is cool. But, I wanted something that I can put off in the corner of the desk, just pop it on at any point in time. And that inspired this project here, which is a Raspberry Pi, basically just a streaming device for Broadcastify. So right now we're tuned into Chicago Police.
They didn't realize that they needed CPD to do presence.
Pretty cool, right? So let me show you how this thing works. So before we get started with the detailed tutorial, let me give you a quick high-level explanation as to what we've got here. So inside the box is a Raspberry Pi 3B Plus with an Adafruit 3.5-inch touchscreen. There is a little cheap amplifier in there hooked up to the headphone jack with another cheap little speaker. The whole thing is powered by a little latch circuit that I designed that gives you the ability to turn this on and off from a push button. So when you press and hold this, it will safely shut down and kill power to the Pi. You press it again, powers it up. The little program you see running here is actually a processing sketch, and that brings in these Broadcastify feeds. So when you go and click one of these, you can go here, click iTunes, you hit play, then you can grab this URL here, and then that's what we're using to stream in these feeds. And the way I did this was actually pretty cool, so check this out. So I've got the VNC viewer connected to the Pi. I'm going to hit escape here. And when that sketch loads, which by the way it loads at boot, so when we power up, automatically launches our sketch. The sketch will automatically load the feeds that I've got here in urls.txt on the desktop. And there's a whole bunch here. And as you press the button, it cycles through each one of those feeds. In fact, check this out. The first one here is actually not Broadcastify. It actually loads in a smooth jazz radio station from internet radio. And there you have it. So I can just press the button again and again, and it just loads through each one of those lines on that text document. So, oops. And then when I let go, it lands at whatever line I wanted, pulls in the metadata from that feed to give you the title there on the screen. And it's as simple as that. The secret sauce to this sketch is the VLCJ video library, which you can go and grab here. Then it's really as simple as preparing the media at that URL. So you could almost just copy and paste that URL right in here. But one of the tricky parts of getting this to work was that those URLs come in as M3U files, which do not play. So all I did was change them from M3Us to MP3s, and everything works. Alright, so based on that, you might be able to figure out how to build all of this on your own. If not, stay tuned because we're going to dig right into this. So I always like to start with the hardware here, and I've got the box opened up so you can see we've got the Raspberry Pi 3 Model B Plus right in here. Those are pretty common. Of course, now they've got the 4 out, which would be total overkill for what we've got here. In fact, maybe even the 0 would be a better choice, especially if you wanted to package this up a little tighter. So then that is attached to the Adafruit 3.5-inch TFT touchscreen. So you know, you go through their little tutorial on how you install that. It's pretty straightforward. Then at the bottom there is the latch circuit. So over on my wiki page here, you see latch power circuit. You can build one of these yourself. It's all through-hole parts. I did design my own little board for it, and that has a 5-volt input to it, and that allows you to have the single button turn on, turn off, and of course it safely shuts down and kills power from a processing sketch. And I did do a tutorial on that, and there you see it's all done on a breadboard. Schematic, there's a bill of material on there, so, and of course I think I've got a couple extra of those boards in case you're interested. Let me know. So one little hack you'll see there is on GPIO 20. I had to pull it up to 3.3 volts with an external 10K resistor. Wasn't too happy about that because these pins do support internal pull-ups, but for whatever reason it was not working in my sketch, so had to add that in, which is fine. We're using the 3.5 millimeter audio output from the Raspberry Pi. You get this little cable here. That goes and feeds down into this audio amplifier, which is a super cheap. And I bought this here on eBay a few years ago. You can use pretty much anything you want though. It just makes it easy when you've got that 3.5 millimeter input. And the output there, we're only using one channel to a cheap speaker. And that's nice because it gives you the volume control right there on the board, feeds through the front panel, and I think that's pretty much it for the hardware. And just keep in mind that we're using GPIO 20 here in the processing sketch to cycle through the various streams and also do the safe shutdown. You don't have to use any of that stuff if you don't want to. I mean, the sketch you'll see is so simple. But just keep in mind that we're using 20, and I've got an external pull-up on 20, so that's right here, 20, and then the pin 1 right here, I believe, is 3.3 volts on the Pi. Let me check that. Yeah, pin 1 is 3.3 volts, so I got a 10K hooked up from there to 20, and everything works great. Alright, now we can get into the fun stuff, which is the software running on the Raspberry Pi. So I'm going to go through the app and all of the code and how that works, but also a couple bonus things like how to get that app to automatically start when the Raspberry Pi boots up, how to safely shut down the Raspberry Pi from that app, and how to keep the screen on, because by default the Raspberry Pi blanks the screen out after a few minutes, and for this I want to glance over at any time and see what feed I'm listening to. So we're going to get into all of that. Let's get started. Alright, so a couple things we need to do to get set up. Obviously a Raspberry Pi. This one was installed and set up using Noobs. We've got the Wi-Fi connected. We've got VNC enabled, which is extremely useful. So if you go to over here, you go to Preferences, you go to the Pi configuration, you can enable VNC. Then on my Mac here, I've installed VNC Viewer, and I'm connected to this Raspberry Pi through its IP address, and now I've got a remote connection into it. So as you see my mouse cursor move here, it's moving down at that 3.5-inch screen on the Raspberry Pi. A lot of people know about this, some don't, so I thought I'd mention it real quick here. Besides this just being a cool police scanner kind of thing, it's also very useful to have an always-on Raspberry Pi sitting there that I can connect to and experiment with, you know, run some code, develop on, do whatever with. So that's what I'm also using this for. And to modify the streams that I'm listening to, or all of those feeds, I've got that urls.txt document on the desktop, and this is what that processing app goes and pulls in. So every time it boots up, it goes and pulls in all of these feeds. So I can go in, VNC in, modify this, add, remove feeds as I want to. So it's a very easy, quick way of doing that as well. And that app, of course, was written using processing, which I've talked about in many videos. So you're going to need to go and install this on the Raspberry Pi. And then you can go and download the project I've got in the description below. That's what I'm running here. And you will need to install a few libraries. So you go to Sketch, you import the library. We'll add library. and then just search for, well, hardware first. Make sure that your hardware I/O library is installed, and then also VLC JVideo. You're going to need that one as well, and that should be it. Now from here, you could just hit play, but first you want to make sure you've got urls.txt here on the desktop of the Raspberry Pi, and then have a couple feeds in there. And I haven't talked about this yet, but I will supply you with a sample urls.txt that I know works, so you can see a couple examples. And then once everything is good, go ahead and hit play on there. And there you have it. It works. Great. So then when you want to go and export this application out so that it can run on boot, or you can start it from the desktop, you'll need to go File, Export Application, export it out, and then in your sketch folder, you will have all the application folders. And the one that I'm running is in the ARM v6HF folder. So if you go in here and you double click on that, execute, there you have it, it runs. Now just while I'm in here, let me just quickly show you how to get an application to boot or start up automatically on boot. So this is the app we want to run. I'm going to right click on that, copy the path out. On the desktop, you right click, create new, empty file. Call it whatever you want, .sh. I've got mine called startscanner.sh. Then in here, I'm going to open that up. And this is this shell script that's going to run that application. So make sure you just copy and paste everything you see here. Sudo, and then paste that path right here. And you can see the path right there matches where I had that application. Save that. Open up terminal. Type in sudo space nano space /etc/ profile, enter. Go all the way to the bottom here, and that's how you start up an app at boot. So what you do, right click on that little shell script, copy path, come back over here, paste it at the end of this file. It'll paste in just like that. Very, very important, put a space and then the ampersand symbol. Control X saves. It'll ask you if you want to keep the name. You hit enter, yes, and then you're good to go. Now from here you could reboot, and it should start that application up. From that app, we're also shutting down the Raspberry Pi, but we want to also kill power when the shutdown is complete. And to set that up, also in terminal, you type in sudo space nano space /boot /config.txt. Go all the way to the bottom here, copy and paste this line right here. DT overlay equals GPIO dash power off, comma GPIO pin equals 21, because 21 is the pin that we use here in the latch circuit right there. So when that goes high, kills power to the Raspberry Pi. So once we get that safe shutdown, the last thing it does is write that pin high, and that's what we use to do the safe shutdown. Control X, it'll ask you to save, you hit yes, everything's good, and now the sketch should safely shut down and also drive GPIO pin 21 high when the shutdown's complete to kill power. And just while we're in the terminal here, I'll show you how to disable the blanking screen. You actually need to get a screensaver app, which then you just disable. So it's pretty simple, and that actually also disables the blank screen. So sudo space apt-get space install space x screensaver. And you're going to want to go ahead and get that, accept everything. Once that is installed, you can go here to Preferences, Screensaver, Disable Screensaver, and that's it. Just kidding. One more thing I want to show you. So when you're setting up those URLs in the list in that text document, Anything from Broadcastify seems to work here. So again, I'm going to go to top feeds, and I want to now add this. So what I'm going to do is click on this feed here, and right over here, player selection. If I click iTunes, that seems to work for me. You might have to try something else depending on what system you're working on. But for iTunes, what happens here is it opens up here, and I get a URL up here. So I'm going to copy and paste that out and show you what it looks like. So I'm back here at the Pi, and I'm going to just paste that URL in right here. And you see that it ends with M3U, which is a playlist URL. What we need, though, of course, which I described earlier, is an MP3 URL. And I wasn't sure if this was going to work or not, but through a lot of experimentation, it works. So that's good. Now I'm just going to save that. And I just loaded the app up again and testing it out here. We're listening.
Northwest side of the fire.
And there we have it. It works. Cool. And I also mentioned that you can get other things to stream in here, not just from Broadcastify. Like right here, Smooth Jazz Florida. I was able to get this to work, but not through the M3U file, rather the PLS file. So when I click here, I get a URL that ends in .pls. All I did was back at the Pi URL, I changed it to MP3, and that worked. So as you can see, it's pretty flexible. You might have to experiment with a few different things, but it seems like you can use this for a lot of different streams. Alright, now finally we can get to the code. Jeez, that took a while. Sorry about all that. Now, in this processing sketch, and I'm going to show it to you on the Mac side just because we got the nice HD screen here, but we're using that VLC video library. There's a lot to it, and mostly what you see in this project here is just a copy job over from one of their examples. So we're using that to bring in those URLs and stream from them. Processing.io is how we talk to the GPIO pins. Alright, and then just skipping down here to the setup, you see the first thing we do is set the GPIO pin there for the red button, which is on pin 20. And I did set this as an internal pull-up resistor, but for whatever reason, I couldn't get it to work. If this does not work, I had to add the external resistor. So just keep that in mind. Then we've got a 5-second delay, and the only reason for this is because this app is starting automatically at boot. I want to let the network get a connection before we go and try to connect to some URL, right? So I've got this 5-second delay in there. It would be kind of nice to have something in here to check to see if we have a Wi-Fi connection before doing anything like a while loop. Just wait. But anyway, this works for now. Full screen, no need for a cursor. Then right here is how we go and read in all of those URLs from the text document. So we've got that absolute path to where that is on the desktop. I'll go back here and show you how to do that. Right click, copy path. Paste it right into your processing sketch right here. And then we get this array of lines. You know, each item in that array represents one line in that text document, which is each one being a URL. Print all of those out in a loop there, and then we set up the VLC there to start streaming from the first item in that array. So we've got this global variable text file index, which starts at 0 here, and that's the first one we connect to. And then just go ahead and kick things off and play that stream. Now you're going to get a ton of errors, which most of them don't make sense to me, but you know, whatever. As long as it works, I'm happy. Okay, and then in the draw loop here, not much is going on. All we're really doing is checking the red button to see if we need to advance to the next stream, or if it was held down for more than 5 seconds, shut down. So I've got this little function here that's called check shutdown, which is over in the shutdown tab. This code might look familiar to you because it's all just a copy and paste job from that latch video I made. So you can go and watch that if you want, but it's pretty self-explanatory. All we're really doing is monitoring that pin if it ever goes low, and also keeping a timer going. So as soon as it reaches above 5 seconds, turn the screen green, and then execute the shutdown command right here. And that's how we do it right here. It's like just from the command line basically, sudo shutdown -h now. That shuts down. GPIO pin 21 goes high, like I showed you before. Releases the latch circuit, kills power to the Raspberry Pi. Pretty cool, right? Also in here, if we do detect that button going low for the first time, call this function here called red button, which I have over on the main tab, red button right here. And right in here, what we do is stop the stream, index that text file index variable. Then if we exceeded the end of the document, so if that index goes beyond the length of that array or the number of URLs we have in the text document, reset it back to 0, and then we go and connect to the new stream at that index we incremented. Start it up and go back. So I also like to show loading the number. So as you saw here, every time I press the button it says loading, loading 5, 6. That's an easy way to keep track of things. And then after it's done loading, you'll see this crap here. That was not a good example. After it's done loading, you see the actual title, which is pulled out of the metadata for the stream. And speaking of the metadata, that's what this little 2-second timer is doing, because sometimes it takes a few tries for it to get that title. So mm.getTitle is what we're pulling out, and you'll see when it runs, it's actually showing it down here in the console. But you'll get every once in a while when you press the button. Let me show you an example. Like you might see this, and then 2 seconds later it goes to the actual title. So that's what that does right there. And that is pretty much all there is to the code. So I hope you found this useful, and again, you can take this and do whatever you want with it, just some sample code. It's basically just a Raspberry Pi streaming device that I happen to use for streaming from Broadcastify to basically make a Raspberry Pi police scanner. Pretty cool, right? Thanks for watching.